Alright, we are going to go for the fourth example of finding the vertex, max or min, domain and range, and axis symmetry of the same equations. We are going to use the technique of completing the square for this equation. So the first step I'm going to do is that I'm going to isolate the first two terms away from the third term by grouping them together like this. Next is that I'm going to factor out the greatest common factor from only the coefficients 3 and negative 12. And the greatest common factor of the coefficient is just positive 3. So by factoring out 3, I'm left with just x squared minus 4 times x. And then keep the plus 15. Now the next step I'm going to do is that I'm going to use, for this parentheses, I'm going to use this little formula called negative b over 2 times a and then square. Okay. Well, it's not, not negative b, positive b, my bad. Positive b over 2 times a squared. Now, our b and a doesn't come from the original step. They come from this parentheses. So our a is the coefficient that goes with the variable x with the highest exponential power 2. So it's the positive one. Our b is going to be negative 4. So we are going to have negative 4 over 2 times a, which is 2 times 1, and then square. But 2 times 1 is 2. Negative 4 divided by 2 is negative 2. Negative 2 raised to the second power is positive 4. So we are going to take this and put it in here. So we are going to have y equal 3 times x squared minus 4x plus 4, but also subtract 4. And then keep the plus 15. And the reason why we're also subtracting 4 is because this step above, x squared minus 4x, is the same as x squared minus 4x, but plus 0 on the inside. Okay, so there's a 0 right there. The 0 right here can be rewritten as a number subtracting itself. So I can pick 100, and I subtract 100, I'm going to go back to 0. But anything at 0, it's just itself. So that's why x squared minus 4x plus 0 can be rewritten into x squared minus 4x plus 4 from up here, but also subtracting itself, minus 4. And then keep the plus 15, of course. Now the next thing I'm going to do is that I'm going to put this inside a bracket, and I'm going to isolate the first 3 terms away from the last term minus 4. And then I'm going to distribute the positive 3 to this term and then to this term inside the bracket. So I'm going to have y equal to 3 times x squared minus 4x plus 4 plus 3 times negative 4 and then plus 15. Well, this thing here is the same as saying x minus 2 raised to the second power. This is negative 12. So we're going to have what? 3 times x minus 2 squared. Negative 12 plus 15 is going to be plus 3. So this is the corresponding vertex form of this standard form. But with this vertex form, guess what? We can tell our vertex is positive 2 and 3. This is the x-coordinated vertex, and this is the y-coordinated vertex. And because we had a minus side, that's how we know the x-coordinated vertex is a positive number. So the vertex, which is h comma k, which is 2 comma 3. The axis symmetry can be found by taking the inside of this parentheses, x minus 2, set it equal to 0, and then you solve for x, which is x equals 2, which is the same as the x-coordinated vertex. So another way of finding the axis symmetry is by stating that it is at the x-coordinated vertex. Now, is it going to be the minimum or the maximum? Well, let's graph out this function first. So we got the vertex 2, comma 3. So the vertex is here. Now, algebraically, it is going to have the minimum value at the y-coordinated vertex. And the reason why it is going to have the minimum value at the y-coordinated vertex is because your function is multiplying by a positive number, which is positive 3. So the parabola is going to open upward, and algebraically, that's how you know that your function has a minimum value at the y-coordinate of the vertex. But graphically, when you graph out your function, you look at your function, or you look at your parabola from left to right, you see that your parabola goes from decreasing to increasing. It's decreasing all the way to the vertex, hits the vertex, and then it's going to switch to increasing. So graphically, that's how you know that there's a minimum value at the y-coordinate of vertex, which is y equal +3. Now, what about the domain? Well, the domain can be found algebraically by recognizing the fact that we don't have any denominator. So that means we don't have any point of discontinuity. So that means we can take any x value, plug it back into this equation, and we'll be able to crank out the corresponding y value of that x value. And we can do that for any x value from between -infinity to +infinity. So the domain goes from -infinity to +infinity. But graphically, how do we determine the domain? Well, graphically, all we have to do is that we take a look at all of the x values from -infinity to +infinity on our graph. And your parabola is going to hit all of the x value all the way to -infinity, and also all of the x values all the way to +infinity as it's going to keep going out both way like that. So that's the graphical way of finding the domain. To find the range, we graph out the function. We look at the y values from the lowest y value all the way to the highest y value. Well, the lowest y value is y equals 3, and the highest y value is all the way to infinity, because your graph is going to keep going up. So it's going to hit all the y values all the way to +infinity as it keeps going. And because we don't have any point of discontinuity at the lowest y value, y equals 3, that means in interval notation, we are going to have the bracket at the lowest y value 3, and it's going to go all the way to +infinity like we mentioned earlier. So that's how we find the vertex, the axis symmetry, and the minimum